Hey, so today I'm going to be doing just a quick little update on my TDA project. I think today we're going to be living in VS Code and looking at a couple algorithms that I did just to get the threshold value. So as you can see right here in a little Jupyter Notebook Markdown, I've put the algorithm so I could reference it back and not have to switch windows so many times. We left off, we got our point cloud, our dissimilarity matrix. Now I'm going to be looking at this threshold value. Basically, what is the minimum distance I want to allow the points to be a part of the complex that I'm going to graph? It's not extremely important, and I could arbitrarily just choose something, but I kind of wanted the data to make the decision for me, kind of get in a good ballpark, if you will. So let's get down here. We have this dissimilarity matrix. That's just like the test one. I did make two algorithms, and I probably could have used either one of them, but I'll let you know the reasons why I chose the one I chose. Uh, this one, I really quickly flattened out this matrix and then removed the duplicates. If you'll notice when you look at this, uh, I don't, I want to, my goal is to get an average value, or in this case, I actually used the third quartile value, which is like 75% of the data. That's what's going to be my, anything that is lower than 75% of the data I'm going to use in my initial complex, and then anything above that, the distances will not be regarded. And in order to do that, I need to basically look at all of the actual distances, but in the dissimilarity matrix, you have a lot of zeros along the diagonals, you have double, because this right here is the distance between the first point and the second point. And this distance is between the second and the first. Second and first, first and second, same thing. Those distances are the same. And so I don't need double the amount. And I also don't need what's the distance between me and myself, right? So how do I take those out, and how do I get the average value? There may be some other ways that I'm not aware of that are easier than what I decided to do, but here I took out all the duplicates and I reshaped it into just a single line, sorted it, and then I floor divided it by 3/4. And what I don't like is that it does take out duplicates, which makes me think about my original data. Does my data have duplicates? Like maybe the first and 133rd is the distance between those points is the same as the second and the fourth. I don't know that I really want to take that out. I don't know how much duplicates are in there, and I don't want to do any unnecessary exploring. I could probably, in essence, just use this. And if it were more of a time crunch, I'd just kind of do something like this, because right now I just need a somewhat in the ballpark value as my threshold to make sure everything works. Later, I'm going to come back and use that as a parameter to vary, and maybe I'll make like a slider or something like that. But it does bug me that it takes all duplicates out, so I did say, well, how can I preserve those duplicates that are not just the reflection? So what I did, I did a little bit more complicated here, and I'm not the most happy with this, but it works, and I did spend some time on it. Um, so what this does is it actually takes this array, and the index has information actually about what I need to take out. So here is the first row. So the first row, I need to take out all points in the first row, or all distances in the first row that are the first and above, if you see what I mean. In the second row, I need to take out all the second point and above. Third row, I need to take out all the second point and above, right? Third row, I need to take out the third, why is it not highlighted? There we go. The third row and above, and so on. So that's sort of what I did, and it's left me with this. I didn't print it out, but it has an empty array here. After it's all done computing, has an empty array, just one single value in an array, and then two single values here. I did put in a couple extra values because that leaves me with three values, and the third quartile just returns the max there. So it doesn't give me any information as to whether it's actually working properly. So I did insert a couple things. And here you have that array, and then similarly you have that array again. It is sorted, and then I've taken and done the floor division. I don't know, I decided to do this floor division because I said, well, I'm using 75% of the data, and that's a lot. Maybe I need to err on the smaller side. I don't think it really matters that much for getting a threshold distance value that's going to determine whether it, at least for, right, because I'm going to make a slider eventually. And I did choose this one partially because I spent more time figuring out how to do this. What I didn't like is that you actually have to, because it's a ragged, it's a list. I like doing lists because then I can append to the list. Initializing a NumPy array, you have to know the size of the end array. Maybe there's another way to do it, but I haven't figured it out. It's so you need to know something about the size, and I don't want to have to make sure I know the size. I want this to be generalizable. I did it good this time. Anyway, so you do have to cast it as an object, so it is a NumPy array of objects, and I'm not really stoked about that, but it works. It's not too bad. So I got the third quartile. I used this, put it into a function. I took the inserted stuff out, so there's no inserted stuff out. Where's that? I also put in this percentage, so I made it a little variable, so you could do the mean, which would be 0.5. You could do the first quartile, something like that. And it returned, or you could just leave it as that third quartile default. And it works nicely, returns everything. You see down here, it looks like the distance that it will be returning. I printed it out twice. The distance that it will be, if anything is lower than 3,371.5, then it will be included in the simplicial complex. If anything's above that, there will be no line basically between those 2 points. So that's all. I did do a little bit more here real quick. I kind of want to pursue this if I have more time. This is a little off subject, but I'll show you my reasoning behind that. I think it would be interesting to show the dissimilarity matrix, the three-dimensional dissimilarity matrix. My initial thought was, well, I could do a three-dimensional plot, and I can put the indexes, and I can put the values or whatnot, and see how that goes. So I tried it with 2 dimensions. Great, it's cool. I actually use this as like the Cartesian product, if you will. It broadcasts an array of ones and multiplies that against a 1 to 100 and gives me this nice square. So that worked. I did try a couple other different things, and the reason why I did that is because it doesn't quite map over to the three-dimensional version. And I'm not sure if that's because I'm thinking about it differently or because the algorithms are a little bit different in the background. For the scatter 3D, it seems like it always wants to, it doesn't like to broadcast things across all the dimensions. It wants an X, Y, and Z most often, and I think that's because it actually like flattens out those initial. So if I put something like that's broadcasting in the X, it doesn't always quite work the way this seems to. So I did a lot of research and I kind of went around and I said, well, how can I do that? Because it's got to be possible. Like, really, what I just want to do is make a box, right? And I came across a lot of contour plots and these fancy things, and they were using mesh grid, and I thought, I think that will prove to be useful in my application. So I did some playing around, and sure enough, I was able to return kind of like a cube of points. Actually, I did a cube. It took 30 seconds to do a 100 by 100 cube, but it did do a big blue cube here, and that was pretty cool. And it's going to be a little interesting trying to annotate over this because I have to figure out the points and connect the points to the text, and it's going to be interesting. But I might do that. I don't want to stray too far off the beaten path. I want to get my project done. But if I find more time, it'd be interesting. I think it'd be a good learning experience. Eventually, I'll take these points out, replace them with the index and the values. And then in an actual Python matplotlib window, I can rotate that and see where those the diagonal is, and I think it'd be interesting, a good visual to throw up there, and I can always have that as something in the future that I can do. It's kind of how I would see it in my head a little bit, and so I thought, maybe I could put that on the window. So we'll see. I don't know that I want to spend too much time getting into the weeds there, but it's interesting. Anyway, so that's going to be my first. So I'm going to do, back to this algorithm, I'm going to do the K1 simplex next, graphing basically the lines between the points. And we've got our 75th percent, third quartile number, and anything below that will be accepted, and tryouts for anything above that will fail, and that's it. Yeah, thanks for watching.